Hello and welcome back to another episode of the Cicada Detroit walkthrough. In this video, we will be covering puzzles 26 and 27. Let's dive in. Alright, now puzzle 26 is going to introduce us to a new concept. That concept being steganography with text, in this case Unicode specifically. So, I don't know exactly what has changed since the time that I first solved this puzzle and today, but originally, if you were to inspect on this text here for part 1 and 2, you looked at it, you would see a bunch of other non-printing characters listed in the text. But for whatever reason, that doesn't show up today. I don't know if it's an issue with the site, with my web browser, with the settings and the dev tools. I'm not sure. But to illustrate what I did see when I first solved this puzzle, I'll take this text and we'll go to a website that shows you non-printing Unicode characters. Paste it in, show me the characters, and we'll see there's a whole bunch of extra characters thrown in that you can't see. These are all Unicode characters that do something other than put text on the screen. Now, there are two ways we can solve this. There is a tool that does this automatically, but even if you didn't know about the tool, there's another way you could go about solving this. So you'll take all the non-printing characters, so you'd get rid of the actual printing ones, you wouldn't need those. Just looking at these, if you look at the digits at the end, so in this case 77, 77, 77, 2E, 63, etc., convert those from hexadecimal into ASCII equivalent values, you would get a plain text URL. In this case, 77 is a W, so you get www. You see where this is going. Alternatively, there is a tool that can do this for you. If you take this text, you go to this tool on Iron Geek, Unicode Text Steganography Encoders and Decoders. Using this first one here, we can put in our stego text, hit decode, and it gives you the exact same result as if you had done it yourself manually. We'll take that, we'll visit that URL, and that takes us to part 2 of 26. Now, we'll play this video, well, we'll play part of this video. You get the point. So, instead, we're going to download this video. We'll see that it is called Cicada 2024.mp4. We'll save that. Now, once again, we are looking at a steganography puzzle. And again, we have no indication as to which tool to use, so we're going to look back at the ones we've already used. If I remember correctly, the only one that supports MP4 is OpenPuff, so we'll be trying OpenPuff. We'll do unhide. We will add our file. We will remove passwords B and C just like before, and once again we'll use the maximum bit selection option. Now we need a password. Now there hasn't been any other hints on this page that indicate what it might be, so we'll just try the file name, Cicada_2024. Hit unhide. We select our file location, and then one of one carriers processed. We got a file called a full commitment.txt. We'll go check that out. Open it up, and it says visit this page first to log your progress. CicadaDetroit.com/NoStrangersToLove989. We'll go there. Your progress has been recorded. Head back here to finish the puzzle. That link just takes you back to this page. We've now finished parts 1 and 2. But first, I forgot to point out one thing on the previous page. This page's URL is as you run around include all 0W char, which would be 0 with characters. That's important because our next part here has more Unicode steganography, this time using 0 with characters instead of not printing character. And now if you inspect this text, you will still see that this one is full of extra characters. So, like this this line, don't give up, has 0 with non-joiner, 0 with space, 0 with non-joiner, repeated multiple times. So, we'll do some Googling, look for 0 with steganography programs, and we'll find this tool. I'll come down here and remember that URL, include all 0 with characters. So, we will include all of them. And then we'll paste in our text. We'll hit decode. This looks the same. However, you'll notice a difference in length, 47 versus 95. Because it's an option to download a file, we'll download that hidden data. We'll give it a .txt extension as a guess. We'll open hidden data.txt and we'll see that it was in fact text. It's a /URL for it hurts you 55433. We'll copy that. We'll go to that URL. And we get another file. It's another wave, and it sounds like this. It's slowed down Rick Astley. It's the same song, just really slow. So we'll download this. We'll see that the file is called I Know We're Playing Hide and Seek, but Does This Song Rock You Too? .wave. We'll save that. Now that file name contains multiple hints for us. There's the part about hide and seek, which is a reference to a steganography program called StegHide. And also there's another program called StegSeek. StegSeek is a lightning fast StegHide cracker. And we'll also see here that it suggests using a file called rockyou.txt as a password attack list. Now, if you're not familiar, RockYou was a company that is famous for having a data breach in 2009 where the accounts of over 32 million users were exposed, and it was revealed that the company was storing their passwords in plain text. And since then, the password list has often been used in dictionary attacks. And now we will use StegSeek on this file with the RockYou password list. Now StegSeek is a Linux application, and I'm currently in Windows, so I can't run it here. I recorded it in Ubuntu earlier, and I will put up that recording on the screen. The command to run it is pretty simple. It's just StegSeek, then the name of your file, and then the password dictionary you're using, in this case, rockyou.txt. Now the program doesn't come with RockYou included. You'll have to find that online. A quick search for rockyou.txt will show up with multiple links where you can download the full password list. Then you just hit enter. And then after a moment, StegSeek will output that it found the passphrase, in this case Cicada_1986. It says that it found a file called youknowtherules2.txt, and it's extracting it to I Know We're Playing Hide and Seek, but Does This Song Rock You Too? .wave.out. And then if we open that file, we will see that it has a URL for us. We'll go to that URL. And that takes us to puzzle 27. Alright, so puzzle 27, we see here that it says hash, and we have a series of letters and numbers. And then it says 9 digits, lowercase, and numbers only. And then it asks us for a password. Now, if you're not familiar with hashes, they're kind of like encryption, except for the fact that it only works in one direction. With encryption, there will be a function to encrypt and decrypt. With hashes, it only goes one way. And unlike with ciphers, with a hash, regardless of the input length, your hash will always be the same length. So what we're going to need to do here is we're going to need to brute force this hash and figure out what text was hashed to get this string. And we have a hint that it was 9 digits long and consists only of lowercase and numbers. Now, you can't brute force it on the website. For example, if I just type in 1234 and hit submit, it'll tell you that you can't brute force it here. So we're going to need to go somewhere else to brute force this hash. Now the first thing we need to do is figure out what type of hash this is. If we take it and go to hashes.com and use their hash type identifier, it will identify that this is most likely an MD5 hash. And now that we know the type of hash, the length of the plain text, and a set of characters that it's composed of, we can try to brute force it. We will do that using hashcat. Now this is a command line program that you can install, and then to run it, I'll walk you through the command. So we start by just saying hashcat, and then the M options, that's the hash type. 0 is the option for MD5, and then the -A option is to specify your attack type. In this case, 3 is for brute force. Then we list out our hash, and the -1 is to define a custom character set. In this case, character set 1, which we will define as being composed of letters, that's the lowercase letters, which is the lowercase l, and digits, which is the d. And then we will specify that for the first character is composed of character set 1, second character, third, fourth, fifth. All 9 characters belong to this character set of lowercase letters and digits. And then the show option specifies that we want to see the cracked hash once it finishes. So we will run that. I think this might have gone faster because I've already run this on my computer before. But in any case, it'll tell you that for this hash, the plain text is C1C4D4313, which is basically just the word Cicada Detroit. This is Cicada with leet speak with a 1 instead of an I and 4 instead of A's, and then 313 is the area code for Detroit. So we'll take that string, copy it, go back here, enter that as our password, hit submit, and it says you've completed the above. Now decode the below. We have this string. This looks like a cipher, so we're going to go to decode, ask it to identify the type, and for the first time in this contest, it's going to give us the wrong type. It says it's ASCII 85 encoding. We can try that, and it just gives us some more gibberish. So it's actually not ASCII 85. We need to look to some other tools to figure out what this is. So we are going to turn to Cache Sleuth, specifically their multi-decoder, paste in this text, hit solve, and we're going to look through the results and see if anything stands out. And a lot of these are just going to look like more garbage, but there's one here, rot47, where we see that it ends with .onion, and what we're looking at here is a .onion URL for the Tor browser. Now the reason that decode failed to identify this is that this whole chunk here is just random letters and numbers. It doesn't actually say anything in like English or any other language, which makes a encryption of it much harder for automated tools to identify. So we will take this. Now I'm using Brave, which has a built-in Tor browser, so we'll go to there, wait for it to connect. Now that it's connected, we'll paste in our browser, hit enter, and we get a page. It says you already have the other key to success. Then we have a cipher. We'll take that cipher, we'll get rid of Tor, go back to decode and see if it can identify what this is. Alright, a very strong match on Visionaire cipher. We'll try that one out. We'll paste in this text, hit automatic decryption, and we'll see that the key is failure. Now if you remember back in puzzle 23, Picasso's key to success is action, but the file we got back from it when we ran OpenStego on it was called or failure, failure being our other key to success. So that's where our key failure comes from. Now we have the plain text. We must embrace our failures, but we must also celebrate our wins. You have done well. To keep going, head to / the cosmos is within us. We are made of star stuff. We'll take that URL. We'll go to that. And that takes us to puzzle 28. Alright, and we'll pick up with 28 next time. I hope you enjoyed. If you learned anything new, please let me know in the comments below. If you solved anything different from me, please let me know about that too. I'm always interested to hear. And I'll see you in the next one.